The real birth of math, many argue, is economics, money. So let's use that for an example then. As you know, math is a system dealing with amounts of something, in our case, cents, which could also be defined as C. Let's say you didn't know how our currency worked, but you know that all money can be counted in cents. So you can buy everything you need with a ton of cents in your pocket. One day you find a bag of coins. There are 6 coins in the bag, and you're trying to figure out how much this is worth. You decide to call these new unseen coins X, and you go to the market to try using them. You find some guy and he says he'll give you 80 cents for 2 of the coins. So 2x equals 80c. You then say, well, how much would 1x coin be worth? And the answer is obviously half of the 80c, or 40c. So 1x equals 40c. Hurrah! You found 6 of them, however, so you just found 6x, which equals 6 times 40c, or 240c. Nice, you now have 240 cents. Every problem in algebra is essentially finding a new coin or two and figuring out how much it's worth. It's a system of how much something equals something else and using that to figure out new things. For instance, now that we know x equals 40c, say we travel to Japan and wonder how many yen or y this is worth. We can look up an exchange rate and find that 1c equals 2y. Therefore, x equals 40 times 2y, which equals 80y, or 80 yen. Most people have a good sense of how money works, but don't get math because the context is taken away. In other words, people understand that 25 cents equals 1 quarter, that 4 quarters equals $1, and obviously then $1 equals 100 cents. But they have trouble with y equals 25x, 4y equals z, thus z equals 100x, which is saying the exact same thing and coming to the same conclusion just without the units of money attached.